Okay, so this is going to be the fourth video in a series about fractions. And you might want to go back to the third video where we talk about factors and primes. In that video, we discuss divisibility rules and we discuss how to find prime factorizations. And that stuff could be really, really helpful in this video, okay? So that video by itself, the third video, seems very separated from fractions, but now you're going to see how it comes into play. So this video is going to be all about simplifying or reducing fractions, okay? So let me go to the whiteboard. Okay. So reducing fractions. All right. Also called simplifying. And this is something that's really, really important. In almost every case that you're going to come up on with fractions, whether you're adding, subtracting, multiplying, dividing, you're always going to want your answer to be simplified, okay? So this here is the process of writing a fraction in lowest terms. Now, lowest terms, you might not be familiar with that. So lowest terms is when we write the fraction so that the numerator and denominator have no common factors other than 1. So this is when the numerator and denominator have no common factors other than 1. So let's look at a couple of really quick examples to see kind of what I mean by that. So consider the fraction 3/4, okay? Now, factors of 3 would be 1 and 3. And again, you can go back to that third video in the series if you need to kind of review what factors are. Factors of 4 would just be 2, 2, 1, and 4. Okay, so I can multiply 2 and 2 to get 4. I can multiply 1 and 4 to get 4. And then I can multiply 1 and 3 to get 3. And if you look at these two lists, the only number we have in common is, 1. All right, well, this fraction would be considered lowest terms because the only factor that is common to the numerator and denominator is 1. Okay, so then let's consider the fraction 15/20. Okay, now if we look at 15, we have factors of 1, 15, 3, and 5. If we look at 20, we have factors of 1, 20, 2, 10, 4, and 5. Okay, so when we look at these two lists, we notice that we have a 1 in common, but what else do you notice? Hopefully you notice that these two lists also have a 5 in common. So this fraction, 5/20, is not in lowest terms. There is a common factor other than 1. So not in lowest terms. And then this one, I'm going to try to write it nice and small. This one is in lowest terms. All right. So our goal is to take a fraction like 15/20 and write it in such a way that it no longer has that 5 in common. And that's the process of reducing. So basically what you do is you want to divide out those common factors. Okay. And there are really two main methods for how to do this. Okay. So two main methods. The first method is factoring out, or let's say dividing out. I think that'll be easier to understand. So the first method is dividing out the greatest common factor. Or it's very commonly known as just the GCF. Now, The greatest common factor is the largest factor a series of numbers have in common. So basically, we're looking to see what the largest factor a series of numbers have in common. So if we go back to this previous example, we looked at 15/20 to see if it was in what's considered lowest terms, and we found out it wasn't. We had that 1 in common, that factor of 1, but we also had a factor of 5 in common. And that happens to be the largest factor that's in common between 15 and 20. All right. So that would be considered the GCF. Okay. So to reduce using this method, we find the GCF. And there are certainly methods to finding the GCF. I kind of have a process I use for finding the GCF. But at the end of the day, there are other ways around it if you don't actually know what the official GCF is. But anyway, you would find the GCF. You would divide the numerator and denominator by the GCF. And then write out the reduced fraction. It's really that simple. Okay, so if we go back to this example of 15/20, okay, I'll do this in a different color so you can kind of see it. We have 15/20. We have already decided that 5 is the GCF, so we could easily divide 15 and 20 by 5. Well, 15 divided by 5 is 3. 20 divided by 5 is 4. And look at what we get. We get 3/4. And we know from this example over here that 3/4 is definitely in lowest terms. All right. Now, the second method that people are familiar with is the prime factorization method. Now, it really is important to go back to that third video because going over prime factorizations is a fairly lengthy process. So go back to that third video on factors and primes to remind yourself of what factorizations are and what specifically a prime factorization is. But just in short, it's a factorization of a number that is made up of all prime factors. So for example, if I was considering 12, all right, there are lots of factors of 12, 1 and 12, 2 and 6, 3 and 4, but there's another factorization, and it is 2 times 2 times 3. If I multiply the 2 and the 2, I get 4. If I multiply the 4 by 3, I get my 12. And you'll notice all 3 of these factors are prime. So that's a prime factorization. So to reduce, you want to find the prime factorizations of the numerator and denominator. All right. Cancel all factors that are common. And you have to be careful with this step. You can't just cancel any factor that you see top and bottom. You cancel them one for one. So if there's a 2 in the top and there's 2 2s in the denominator, you can only cancel that 1 2, the one that's in the top and the bottom. So we cancel factors that are common, and I'll show you this just to make sure we're clear. And then the product of the remaining factors is the reduced fraction. All right. So just really quickly, we're going to go back to that previous screen. And we're going to look at this from the prime factorization standpoint. All right. So if I look at 15 There are two factors of 15, 3 and 5. They are both prime. So that means this is the prime factorization of 15. So I'm going to go ahead and write that out. If I look at 20, let's say I come up with two factors of 24 and 5. Well, 5 is prime, but 4 is not. So I need to break down 4. So factors of 4 would be 2 and 2. And so now I bring down that 5 and I have three factors of 20. All are prime. So I come over here and I write out that factorization. I want to cancel anything that's in the top and the bottom. So notice the 5s cancel. And the product of whatever is left is your reduced fraction. So in the numerator, I just have a 3. In the denominator, I have 2 times 2 or 4. So earlier we simplified this fraction by just dividing out the GCF. Here we did the same exact thing by reducing the fraction, except we used prime factorizations. Now, either of these methods are fine, okay? Most people, however, don't commit to one method or the other. They actually do a hybrid of the two. So we're going to do a few examples where I show you the GCF method, and then a few examples where I show you the prime factorization method. And then I'm going to show you how people kind of do the hybrid of the two methods. So you've kind of like, you're going to have several examples across the board, and you can choose the method you prefer. All right. Let me go to the next screen. Okay. So let's consider 10/40. Now, for 10/40, it's going to be fairly easy to see what the GCF is, but I want to show you my process. So what I do is I take the smaller number, whether that's the numerator or denominator, I take the smaller number, and I consider the factors of that number. So if I'm looking at 10, factors of 10 would be 1, 10, 2, and 5. And I go through this list of factors largest to smallest, and I see if any of those factors are also factors of the second number. So the largest factor of 10 would be 10. Does 10 go into 40 evenly? Well, yeah, it does. So that tells me that 10 is my GCF. So I want to take 10 and divide it by 10. I want to take 40 and divide it by 10. Well, 10 divided by 10 is just 1. 40 divided by 10 is 4. And you can see that 1/4 will not have any common factors other than 1. So 1/4 is the reduced answer. All right. Let's look at 12/40. Okay. So again, remember in this method, we're looking for the GCF. Okay. So this is the GCF. So like I said just a moment ago, I take the smaller number in the fraction. In this case, that's the numerator, 12. I find all factors of 12. So that would be 1 and 12, 2 and 6, 3 and 4. And I go through this list of factors largest to smallest, and I see which of those factors would go into the denominator. So we start with 12. Does 12 go into 40? Well, no. We go to the next largest factor, which is 6. Does 6 go into 40? Well, no. And you can kind of test this on a calculator. I certainly want you to not become so reliant on your calculator, but a simple check, 40 divided by 12, you'll get a decimal. 40 divided by 6, you'll get a decimal. All right, so 12 and 6 do not work. So that leads us to the next largest factor, which is 4. Well, does 4 go into 40? It certainly does. So we're saying here that the GCF is 4. So I divide both the numerator and the denominator by the GCF of 4, and I get 3/10. And you can see that 3 and 10 have no common factors. The only factors of 3 are 1 and 3, and neither of those go into 10. All right, not too bad. All right, so let's do both of these same fractions, okay? So 10/40 and 12/40, but this time we're going to do the prime factorization method, okay? 10/40. So using the prime factorization method, we find the prime factorization of the numerator and the denominator. So factors of 10 would be 2 and 5. Both are prime. So that's the prime factorization. Now 40, there are a couple of different ways you could get the factorization of 40. For this one, let's just say we use 4 and 10. Neither of those are prime, so I'm going to keep going. 4 could be written as 2 times 2. 10 could be written as 2 times 5. All of those factors are prime, so I'm going to write that out. All right, and now we want to start canceling common factors. There is 1, 2 in the numerator, so that 2 is going to cancel only one of the 2's in the denominator. There's a 5 in the numerator that cancels a 5 in the denominator. And this is a good example because a lot of students get hung up here. They're like, okay, things canceled. What do I put in my numerator? Keep in mind, when things cancel in a fraction, it's not like the numbers just cancel willy-nilly. They leave behind a footprint of a 1. So for these 2's, we would say 2 divided by 2 is 1. 2 divided by 2 is 1. So we're really leaving behind a little footprint of a 1 when we cancel. And we get really lazy. We're like, oh, they cancel. And we forget to write the little 1 that's left behind. Same thing here and here. So nothing else will cancel. In the numerator, I have 1 times 1. In the denominator, I have 1 times 2, which is 2. 2 times 2 is 4. 4 times 1 is 4. So there you have it. All right. And you can see that regardless of the method we chose, we got the same answer. All right. Let's repeat the process with 12/40. All right. We're going to come down here and we're going to look at 12. Factors of 12, you could use either 3 and 4 or 2 and 6, does not matter. 2 is prime, 6 is not, but I could rewrite 6 as 2 times 3. So there we have the prime factorization of 12, 2 times 2 times 3. So I'm going to go ahead and write that out. And then we look at the 40. Now, as far as prime factorizations go, it does not matter what factors you start with. Okay, your process may look different depending on the factors you start with. As long as the final factorization is the same, you're fine. So over here, we did the prime factorization of 40. I'm going to redo it using different factors. So instead of using 5 and 10, I'm going to use, or excuse me, instead of using 4 and 10, over here, I'm going to use 5 and 8. I just want to prove to you that it doesn't matter which factors you start with, you'll get the same answer. Okay, so 5 is prime, I bring it down. 8 is not. So I would rewrite 8 as 2 times 4. 5 is still prime, so I bring it down again. 2 is prime. 4 is not, so I rewrite 4 as 2 times 2. So up here, the prime factorization of 40 is still 5 times 2 times 2 times 2. Now we start canceling. There's a 2 that I can cancel. There's another 2 that I can cancel. In the numerator, remember, I've got those little footprints of a 1 for everything I cancel, so I get 1 times 3. In the denominator, I get 5 times 1 times 1 times 2, or 10. So you can again see that regardless of the method you choose, you're going to get the same reduced version of the fraction. So a fraction only reduces to one lowest terms answer. Okay, so if you like one of these two methods a lot, go for it. Okay, now a lot of students do a hybrid method. Okay, they don't really completely do the GCF method. They don't completely do the prime factorization method. They kind of blend the two. Okay, now I will tell you this right here, and I'm going to use a different colored ink. This is the fastest method. So if you can find the GCF, that's definitely going to be the quickest way because you're only going to have to do one division. Okay. However, it's not always super duper easy to know what the GCF is. For the examples on the screen right now, the GCF was easy. You could kind of go through your head really quickly and determine what the GCF is. Other fractions, it's not quite so clear. Okay. So let's look at some more examples. Let's say that we have 18 over 30. Now, if you see what the GCF is, go for it. Just divide the GCF out of the numerator and denominator and be done with it. But let's say you don't see the GCF, but you can acknowledge the fact that 18 and 30 are both even. Okay, so if numbers are even, they're divisible by 2. And that kind of goes back to one of those divisibility rules from the previous video. So I know that these at least have a 2 in common. Whoops. So I'm going to divide both the numerator and denominator by 2. Well, 18 divided by 2 is 9. 30 divided by 2 is 15. So we have to ask ourselves, is 9/15 fully reduced? Well, no. 9 and 15 actually have a common factor of 3. So I would divide 9 and 15 by 3, and I would get 3/5. And at this point, 3 and 5 have no common factors other than 1. This would be your reduced answer. So in this method, we're not really doing the prime factorization. We didn't find the GCF, but we're just finding any factor at all that the numerator and denominator have in common. We divide it out, and then we just repeat the process until we achieve lowest terms. Okay, let's look at 55 over 75. Okay, now one of those divisibility rules that we talked about in the previous video is for 5. Numbers are divisible by 5 if they end in either 5 or 0. Well, looking at these two numbers, it's very clear to us that they are both divisible by 5. Now, we don't know if this is a GCF. It could be, but we don't know. But for now, we're just going to go with the division of 5. So 55 divided by 5 is 11. 75 divided by 5 is 15. Now, do 11 and 15 have any common factors? Well, no. The only factors of 11 would be 1 and 11. 11 does not go into 15. This is lowest terms. It just so happens that 5 was the GCF. All right, let's try 16 over 80. Okay, same thing. Let's say we don't know what the GCF is, okay? But we do acknowledge that 16 and 80 are both at least divisible by 2. They're both even. So we could divide by 2. Well, 16 divided by 2 is 8. 80 divided by 2 is 40, excuse me. All right, you can see again that both 8 and 40 are even, so they're at least divisible by 2 again. Now, again, if you find bigger factors that are in common, it's going to be quicker. I'm just showing you that no matter what factors you use, you can reduce this. It might take multiple steps, but you can get it done. 8 divided by 2 is 4. 40 divided by 2 is 20. All right. And now let's say that you're like, okay, 4. I recognize that 4 goes into 20. So that would make the GCF of 4/20, 4. So 4 divided by 4 is 1. 20 divided by 4 is 5. All right. So it took us a few steps. We didn't necessarily know right off the bat what the GCF was, but we were still able to reduce the fraction. It would certainly be quicker if you knew the GCF right off the bat. But if you don't know the GCF, as long as you can find a common factor, you can reduce a fraction. Let's try 40 over 48. All right. So 40 over 48. One of the division rules, like one of the divisibility rules, is 1 for 4. If the sum of the last two digits are if the last two digits rather are divisible by 4, then the whole number is divisible by 4. Well, looking at 40, 40 is certainly divisible by 4. Looking at 48, it's certainly divisible by 4. So we don't really have to do the last two digits because these numbers are both only 2 digits long. But remember that divisibility rule. So we could divide top and bottom by at least 4. Let's see what happens. 40 divided by 4 is 10. 48 divided by 4 is 12. And it looks like 4 was not the GCF. We have 10 and 12. They're both even. We know that means they're at least divisible by 2. So we would divide by 2, and we get 5 over 6. Now, at this point, 5, the only factors of that would be 1 and 5. 5 does not go into 6. We have lowest terms. Okay? Let's try 21 over 30. Now, another one of the divisibility rules is for 3, and it says if the let's see, the sum of the digits is divisible by 3, then that number is divisible by 3. So let's look at 21. If I add 2 and 1, I get 3. 3 is certainly divisible by 3. If I look at 30, I add those two digits. 3 plus 0 is 3. 3 is divisible by 3. That means both the numerator and denominator are, in fact, divisible by 3. 21 divided by 3 is 7. 30 divided by 3 is 10. It just so happens in this case, 3 is the GCF because 7 and 10 have no other factors in common. All right. Let's try, I want to find another good one. Let's do 36 over 80. Now, for 36 and 80, 80 is a little bit bigger, might be hard to find the GCF. So we recognize that the numbers are both even. And anytime you have even numbers, they're divisible by 2. Let's just go ahead and start with dividing by 2. Well, 36 divided by 2 is 18. 80 divided by 2 is 40. Good grief. Now, they're both even again. So let's go ahead and divide by 2 one more time. 18 divided by 2 is 9. 40 divided by 2 is 20. And let's see if we have any common factors. Well, factors of 9 would be 9 and 3. All right. Well, 9 does not go into 20. 3 does not go into 20. So 9/20 is lowest terms. Okay. Let's try a few more examples. I want you to see as many examples as possible. Let's look at 42 divided by 70. So if you see the GCF is always going to be quickest, okay? But maybe you don't see the GCF. So let's just go ahead and start with a process. Let's find any factor that these two numbers have in common. Again, like several of the previous examples, we can see that 42 and 70 are both even. So I would divide top and bottom by 2. So I would get 21. So 42 divided by 2 is 21. 70 divided by 2 is 35. All right. So now we have to determine a factor that 21 and 35 potentially have in common. Well, 21 would be divisible by 21, obviously. It would be divisible by 7 and 3. Well, 21 does not go into 35, but 7 does. All right, so let's divide both of these by 7. 21 divided by 7 is 3. 35 divided by 7 is 5. And 3 and 5 have no common factors other than 1, so we have a reduced fraction. Let's try another one. Now, 66 and 99. This one's a little tough, all right? Both numbers are not even, so we can't divide by 2. 3 is not going to work. Well, 3 could work. No, 3 is not going to work. Yeah, it would. So let's try 3. There's a bigger factor that's a little bit more obvious. You could try 11, but let's go ahead and just do 3. So 66 divided by 3 would be 22. 99 divided by 3 would be 33. All right. Now we've got 22, we've got 33. They're not both even. What are we going to do? We have to find some factor. And it just so happens when you have double digits, like if you have the 66, the 99, 22, 33, 44, 55, 77, 88, when you have those double digits, it's always divisible by 11. So you could have started off with 11 if you wanted to, but we can do 11 now. So 22 divided by 11 would be 2. 33 divided by 11 would be 3. 2 and 3 have no common factors, so you have a reduced fraction. All right. So let's look at a few more examples and we'll wrap up this video. You could have improper fractions, and as far as improper fractions are concerned, they divide out the exact same way a proper fraction divides out. Whether or not you write your answer as a fraction, an improper fraction, or a mixed number is up to you or the directions in the problem. For me, I generally keep everything improper unless the directions ask me to write my answer as a mixed number, or sometimes if I'm dealing with a word problem. Oftentimes word problems make more sense when the final answer is a mixed number versus an improper fraction, okay? But as far as just taking simple examples and reducing them, keep your answers improper. So 49 and 21, this is kind of tough, all right? So if you wanted to, you could do that method that I showed you way back at the beginning of the video. where we looked for, well, that's not it. Let me go back to this slide right here. In the top two examples, we were looking at factoring out the GCF. And so what I did is I took the lower number in the fraction and I started finding factors of that number. I went through all of the factors and went largest to smallest until I found a factor that was common with the denominator. So if we look at 12/40ths, the factors of 12 would be 1, 12, 2, 6, 3, and 4. And so I would start with the largest factor, 12. Does 12 go into 40? No. I move to the next largest factor, 6. Does 6 go into 40? No. I go to the next largest factor, 4. Does 4 go into 40? Yes. That makes 4 the GCF. So let's kind of do that process over here with 49/21. So factors of 21 are 1, 21, 3, and 7. Well, does 21 go into 49? No. Next largest factor is 7. Does 7 go into 49? Yes. So divide top and bottom by 7. Well, 49 divided by 7 is 7. 21 divided by 7 is 3. So the final answer would be 7/3. Again, for the most part, I just stick with the improper fraction. I would say you're going to see improper fractions probably more often than you would see mixed numbers. But if you did want to convert this to a mixed number, for example, if you had a word problem or if the directions specifically asked, what you would do is ask yourself, will 3 go into 7? Sure. How many times? Well, 3 goes into 7 2 whole times with 1 left over. So it would go 2 1/3 times. Now, again, 7/3 is generally going to be the preferred answer, but don't forget how to convert those mixed numbers to improper fractions and vice versa. All right, let's say we had 36/30. Well, it doesn't matter what method you use, whether you do the prime factorization method, the GCF method, or the weird hybrid method. Let's say in this example, you kind of quickly realize, hey, 30 and 36 are both divisible by 6. We divide top and bottom by 6. Well, 36 divided by 6 is 6. 30 divided by 6 is 5. So we get 6/5. Or 5 will go into 6 one time with 1 left over. All right. 25/10. All right. So we look at 25 and 10. What do they have in common? They both end in 0 or 5. So that means they're divisible by 5. Whoops. 25 divided by 5 is 5. 10 divided by 5 is 2. So there we have it. Or if you really want the mixed number, 2 will go into 5 2 whole times with 1 left over. All right. One last example. Let's say we have 64/16. All right. Let's say, just pretend this is one of those examples where you're like, gee, I don't know what the GCF is. Let me see if I can find any factor. Well, we can acknowledge that they're both divisible by at least 2. They're both even. So we could start with that. 64 divided by 2 is 32. 16 divided by 2 is 8. And maybe at this point you're like, ooh, I realized something about this. I'm pretty sure 8 goes into 32 evenly. It does. And you can also remember that this bar right here, this fraction bar, really just means divide. So we could go ahead and say 32 divided by 8 is 4. Now, in this particular case, you would not want to write this 4/1. You would want to go ahead and simplify it to just the whole number 4. All right. So hopefully this helps give you an idea how to reduce. Remember, reducing or simplifying fractions is the process of writing the fraction in lowest terms. And that is specifically when the numerator and denominator have no common factors other than 1. There are 2 main methods that are generally taught in textbooks. The first method is dividing out the greatest common factor, or the GCF. You basically find the GCF, which is the largest factor a series of numbers have in common. You divide the numerator and denominator by the GCF, and then you just write out your reduced answer. All right. The second method is the prime factorization method. So just recall a factorization is writing a number as a product of factors, and a prime factorization very specifically is a factorization of a number made up of all prime factors. We generally use factor trees to find prime factorizations. More details about that in the previous video. Now, to reduce using the prime factorization method, we find the prime factorization of the numerator and the denominator. We cancel out common factors top to bottom, and then the product of the remaining factors is your reduced answer. So we did a couple of quick examples doing the GCF method, which generally is going to be your fastest method. If you can see the GCF right off the bat, that is hands down going to be the quickest way to reduce your fraction. It's also the method where you have the fewest number of steps. Okay, and the fewer steps you take, the less likely you are to make a mistake. So there's definitely some merit behind the GCF method, but sometimes it's not super obvious what the GCF is right off the bat. So that leads us to the other methods. We also showed the prime factorization method of these two examples. And then we did several examples where we did that kind of hybrid method. So here's a good example of the hybrid method. We pretended we didn't know what the GCF was, but we knew that we had at least a factor of 2. We divided it, still wasn't reduced. We divided another factor of 2 out, still wasn't reduced. So we divided another factor of 4 out. This method is fine. And I, in my experience, have found that most students do this method. They just divide out any common factor and they repeat the process until they achieve lowest terms. All right. We also looked at a couple of examples where we had improper fractions. Keep in mind, with improper fractions, generally speaking, an improper fraction is going to be what you're going to see. Okay. I see improper fractions probably a bit more often than I see the mixed numbers. However, there are times where the mixed number is absolutely necessary. Word problems. When we're dealing with word problems, to say we have 7/3 of something oftentimes doesn't make sense. Whereas if we say we have 2 1/3, it makes sense. So if we're talking pizzas and I say, hey, I ate 7/3 pizzas, well, that doesn't really make sense. But if I say, hey, I ate 2 1/3 pizzas, that makes much more sense. So word problems, oftentimes you're going to want to convert your answer to the mixed number. A lot of times too, if you start with mixed numbers, you end with mixed numbers. Okay, so don't get lazy about knowing how to convert your improper fractions to mixed numbers, because there are times where that mixed number is going to be preferred. Okay, so I hope this helps as far as simplifying fractions goes. It is going to be beneficial to you to watch these videos. We're on the 4th video in the series. It's going to be beneficial to watch them in order. Okay, so if anything in this video didn't really make sense, you probably missed something in one of the first 3 videos. So go back and watch the first 3 videos. And then next up in the 5th video of the series, we're going to talk about comparing fractions. And that just means we're going to look at 2 fractions and determine which one is bigger. All right, hopefully this helps. Best of luck.